Okay, so let's begin. I just spoke to all of you guys to know your background and stuff like that. Few of you said you guys already knew Java, and few said you guys did not start Java. So entire this course structure is meant, like, probably you guys must have seen how it is being divided. So we are going to begin with core Java, and then move towards like JSP servlets, like Java EE platform, and then move towards frameworks. Okay. So probably if you guys are looking for jobs, like you got to go till framework stuff. Like that's where like most of the people now use Spring and Hibernate and all that stuff. Okay. So if you guys want to start from scratch, yeah, core Java is also must. Like any interview that you go to, core Java, people start asking from there. Okay, fine. So if you know already, maybe you may feel like slow in the first few days, but eventually we catch up. Okay, so don't worry about that. And for each of these sessions, I have something called an objective. So make sure you follow that objective of the session. So end of the session, you should be able to understand, and you should be able to answer the objectives of the session. So that's when we're doing justice for the course structure. Otherwise, it's like I go in one orthogonal direction and you guys go in another direction, and it doesn't make sense. Okay. So this is what I want to make sure. Objective of the session, like if you guys have any questions, this is the time to talk about um, course structure. Like that's why I sent an email before. Do you guys have any questions about the course structure that we are following here? If not, I just move forward. Let me know if you guys have any questions. uh, I am muted, you guys. If you guys are speaking, I cannot hear probably. Yeah, if you have any questions, let me know. Otherwise, I'll move forward. Okay, doesn't seem like any questions around. Okay, so I'll just show the course structure when you guys are here once. So we can just briefly go through it. Okay. So here is the thing. So previously I used to do day-wise, but I cannot do day-wise anymore. I work for a startup, so that's why I put it as a weekend. This is the thing. Like, idea is to cover each of these that are being mentioned on a weekly basis, and let's see how far we can make progress. And based on that, we can adjust it accordingly. But I'll try to follow this, at least this flow. Okay, fine. Okay, let's move on. Can you see my PPT? Everybody can see my PPT, right?
Yeah.
Okay. Oh yeah, I'm muting all of you guys off. All right, fine. Let's. Okay. So objective of today's session is discuss the course structure, learn what Java is and what it is not, and why Java is being used, and advantages and disadvantages of Java. Understanding what is JDK, JRE, path, class path, and JVM, and should be able to install Java on all of you verse environments, and you should be able to run at least a small program by end of this course. Okay, by end of this day session. All right, let's move on. What is Java? It's actually a general purpose programming language and fully object oriented. Like traditionally, if you guys are did C programming, which is actually a structured programming language or procedure oriented programming language, and whereas Java is object oriented. C++ and Java are object oriented programming. We'll see like what is object oriented and all that. And it was originally developed and maintained by Sun Microsystems. Now Oracle took over, but it was originally developed by Sun Microsystems. And then similar to C++, like people who were from C++ background could able to pick up Java pretty quickly. But if you even don't know C++, which is good, it's same with me. It's even more fresh, and you can understand the concept. No confusion. Okay, let's move on. Okay. So what Java is not? First thing that you should know is what Java is not. Like when I started working in US, I was in the one of the like regional transit stops, and I was talking to a guy, and he was like, "Oh, what do you do?" I said Java. Oh, Java. I run JavaScripts at my work every day. So people usually get confused what Java is and JavaScript is, but Java is not JavaScript. Okay, Java is a platform, it's an application programming language, and it's an object oriented programming language. Even JavaScript is object oriented, but it's not on the server side. Okay, it's on the client side. Like any of your browsers have like JavaScript validations and client side validations and all that stuff. So Java is different and JavaScript is different. That's totally a scripting language, and which is getting matured day by day. Like jQuery, you guys must have heard jQuery, prototype, and all that stuff. So all that is JavaScript, not Java. But if you know object oriented stuff, you can apply that programming concepts anywhere and everywhere. But you like even in the interviews, oh, did you work on JavaScript? You should not talk about like, oh, I worked on Java. Okay, so please be clear. And it's not HTML. Like in early in 90s when actually Java was out, like there were a lot of web UI interfaces, like client side applications like calculator and stuff like that. People used to think like that all has been done in HTML, but people used to think Java and HTML were same. Now probably now you guys don't have that confusion anymore because HTML is totally different. Okay, let's move on. And other misconception. Um, like anytime you have a question, feel free to ping, so I'll know. Otherwise I'll be going in my direction. Okay, fine. Okay, other misconceptions are Java is too slow. Yeah, agreed. Mm, it was slow at some point, and yeah, compared to all the scripting languages today, like Python and all that, which where you can do a lot of stuff in no time. But Java is not too slow. Given the advantages that it gives us, it's not too slow. Okay. And then Java is purely for the internet. It's not the case. You can do standalone applications, you can do web applications. We'll talk about what is standalone application, what is web application, and all that. Don't get overwhelmed with the terminology, but just focus on what we are talking about. And applets are not secure. Like traditionally, all this core Java has this applets and the swing and all those implementations. Those were all not secure was the original thought, but internal Java is platform independent, and it makes it really secure. Like when the architecture is being designed itself, they have some security in mind. Yeah. So these are all the misconceptions. End of this session, you should be able to talk about all these. Let's move on. Okay. Different flavors of Java. Okay. This is what I was talking about, like core Java, enterprise Java, and micro edition. So we're going to deal with standard edition, which is like core Java, JDBC, and all that. Java EE has all this platform like JSP, servlets, like how to write web applications, how to make like Java class, web component, and all that stuff is being dealt in enterprise edition. And also it has something like JMS, like how two different clients can communicate, how to send an email, and all this kind of stuff is handled in Java enterprise edition. And micro edition is generally being used in mobiles, like now that Android and all this stuff are out, and iOS platform. So not many people may use Java ME, but Java ME may be used in doing something embedded, like refrigerators have some control system, right? It has like people say it uses embedded C or stuff like that, but there are few that actually use Java micro edition as well at some point. But now maybe it is traditional. So we don't cover micro edition, by the way. I never worked on micro edition as well. So Java standard edition and Java enterprise edition is what we are going to look at. Okay. So this is just to give you some overview of what Java 2 platform is. Like always, you guys must have heard growing up, like, oh, J2E, what are you doing? J2E. J2E is so famous. Like Java version 2 was so famous and it was there for quite some time. So the platform, enterprise edition platform that came up with Java 2 is actually J2E. Okay. Now we no longer say J2E. We have to say like Java E, Java Enterprise Edition. There is no longer a version 2 there. Okay. Then here, Java technology, like this is all like if you were to use something on the mobiles and pagers and stuff like that, you were using micro edition. And if you were to use, what is this desktop technology? I kept talking about desktop technology, desktop applications, and all that from the time we started the session. Desktop application is something like the GoToMeeting client that you have right now, right? That's actually a desktop version. Okay, that means something is being installed on you on the client system. Okay, that is called. Were you guys able to see it? Okay. So something is installed on the client system. You guys are client, and I'm the server here. Say for example, something is installed on your system for this meeting to be run. That is called a desktop application. And if nothing needs to be installed, like Google Chat, say suppose, okay, not the Gtalk that you install. I'm talking about Google Chat, where you need not install anything. If you have a browser, you're up and running. Emails, if you have a browser, you can run it, right? So that's actually a web interaction there. Whereas if it is a desktop application, you have to install something on the client machine for it to run. Okay. So if you don't know the difference, now you should be able to visualize it. That's why I'm just throwing it out. Then enterprise edition, which has like you might have heard people talking about like, oh, we have a bunch of servers, we have to configure those servers, we have to implement something like clustering and all that. So those all technical jargon comes in the enterprise edition. Like if you're talking about Amazon application, that's actually an enterprise application wherein it's always available, and it has to be like available for people to shop around, and yeah, for it to process your payment transactions and all that stuff, right? And it has to be secure as well. So all those comes in if you are going towards enterprise edition architecture. Okay. So this is just to give you some background and little breather about what is this platform all about. Okay. Any questions, or can we move forward? Yeah, just keep saying something on the chat. Otherwise, I don't know whether you guys are there or not. So I just want to keep it interacting as well. If you guys want, I can unmute all of you throughout the session. So make it interactive. Are you guys around?
Actually, the
Yes.
chat is not
Yeah.
working.
Oh, for you guys, chat is not working.
Uh,
It
oh
should
yeah,
work.
it's there now. It
Yeah,
is
yeah,
there.
it should work. Yeah.
Yeah, it's there. Sorry.
Okay, are we doing okay so far? Or confused already?
No, it's
Oh,
No,
clear.
we are fine.
okay.
I'm fine.
Yeah. Okay. Okay. Okay, Java Standard Edition, whatever I talked about, like it has core language, like what Java language is all about. It has it, and compiler, like um, if you write a Java code, it has to be compiled. Like that means it has to be converted to something an interpreter can understand and execute. Like if you are coming from a C programming background, I just want to give it a try. Like, okay, you have compiler and you have a interpreter who runs it. Okay, so in the same way, all these core libraries and all that stuff are being given by the standard edition. And support for writing all your enterprise applications and applets is also being given by the standard edition. Java Enterprise Edition, what does it have? For enterprise level applications, Corba is like a broker architecture, like in between two different systems, how exactly we communicate. Okay, all that has been uh, part of Enterprise Edition. Now, probably nobody uses this Corba architecture, but they may use that design pattern. And it has EJB's web development, like our coming courses after core Java is all about servlets, JSPs, and how all these frameworks that we fancy frameworks that we talk about, Spring and all that in the late like last sessions, was all like how all these servlets and JSPs get converted to those framework components, all that we talk about there. And also messaging is all part of this enterprise edition. Okay. And XML, what is XML? We'll see all that. Just to give you what is enterprise edition, these are all part of enterprise edition. There can be more as well. Yeah. Okay, just to give you a pictorial representation of what even I said J2EE here, it's actually Java EE, okay? But architecture remains the same, just that more and more components keep adding here. Like to give you some background, okay, you are on a browser, say for example on Amazon shopping cart, and you were sending some request to the server, and there is something like a servlet or a JSP, like depends on the technology. If you are using Java EE platform, like some controller, this is all MVC, okay? Model, view, and controller. Controller is our browser. This one, client invokes the controller, like servlet or JSP is a controller, and that actually does some business function based on what you need to do using RMI or something. And then it has inbuilt implementations of security, transactions, and all that stuff. What is all these transactions all about? Say, for example, you purchase something on your credit card, and you're done with it, right? Like once you're done with your purchase, it should be done. It should commit your transaction. If it keeps it open, if somebody else comes in and tries his own card, they should not be using your transaction details. You're done, right? Done deal. Like you entered something, you purchased something, you're done. You're mutually exclusive to the other purchase. So all the transaction thing, and also if you're doing something else subsequently, it should ask you your details again. Like basically the thing is, it all should be atomic. It should not be like, okay, I carry it forward and I use it further. Like it should all be like then and there completed. Okay, atomic. He gave me details for just this purpose and I'm using it, I'm done. Okay, so those all are being handled using this transaction management and all that stuff. And concurrency, like if multiple people logging in simultaneously, each of them should be treated differently, different threads and all that is handled in concurrency package. Okay, so this is all the enterprise. Like if you were talking to a database in the backend, so how the JDBC is the one which helps us in interacting stuff. Okay, so don't be overwhelmed. Even I was also overwhelmed when I was getting trained on Java EE, but eventually it will all be easy. So just look at it and be with open mind before even getting into like, oh, it's all confusing. Okay, just if you understand this pattern, it will all be easy actually. Java micro edition, it's all used for devices where memory is a constraint. Now, these days, memory is not at all a constraint. That's why we have OS on the cell phones, which can do a lot of stuff. Whereas in the olden days, when we have the initial version of micro edition rolled out, we can't do much. Like memory is very limited. Now, advantages of Java. Why are we learning Java? It's like job is first thing, right? But what are the advantages? Portability at the binary level, not source code level. That means you can write your Java source code here and you can ship it to anywhere else. Just converting it like a archive, like a runnable format. The person who is running it need not know how the source code looked like, but you can ship it. That means any of the servers like these Amazon server or Netflix that you deal with, we don't know the code, we just see the execution of that code, right? So it's portable that way, like geographically you can put it anywhere and it runs. So when Java rolled out, this particular portability is a big thing. Okay, now that everything is portable, that's okay, but this was one of the advantages when they rolled out Java. And runtime is the platform specific, not compiler specific. So runtime meaning like you compile the code and you shipped it to everybody, and it just runs there same as how it is run in the original source machine where the Java source code is written. Okay, that means it is using the runtime, like while executing, wherever you are executing, it is just using some internals of that OS and just executing it doesn't depend anything on where it is been compiled and all that stuff. Okay, so that's the advantage there. Simplicity. Memory management, like if you are coming from C++ backgrounds, you guys have to do all the stuff like construction, destruction of an object and all that stuff. But here memory management is inbuilt. Agreed, you guys have to do, yeah, try invoking garbage collection and all, if you heard about it. But uh, to some extent, compared to C++ developer versus Java developer need not know much bunch of stuff that C++ developer used to do by himself, because JVM, like the runtime environment, takes care of it. Okay. And pointers, there are no pointers is one of the most confusing part in the procedure oriented programming, probably. So there are no pointers here to the programmer, but behind the scenes there are pointers. Okay. And then assignment versus equal to, like there's this double equals was not being supported by a bunch of procedure oriented programming, but that's been supported, but we need not take that as an advantage today. Multiple inheritance, like Java supports multiple inheritance as well, but this is one of the most frequently asked interview question. Okay. Does Java support multiple inheritance for today? Yes. Okay. Um, it is still yes by the end of the course, but how it is different from other programming languages, we'll learn about it. Okay. So you guys learned one interview question today. Does Java support multiple inheritance? Okay. Yes, it supports multiple inheritance. Okay. And another advantage of it is it's open source, so it's free. Anybody can download and anybody can run it. Okay. Fine. Platform design goals. Okay. Platform design goals. While creating this platform itself, we have stuff like portability, architecture neutral. That means whether you run it on Windows or Linux or Mac, anywhere, the execution of it is same. It doesn't really depend on the OS. That's why it is architectural neutral. And high performance, like using this multiple threading and all that inbuilt concurrency APIs, you can do bunch of stuff like that actually improves the performance, though it is slow it to begin with. But with all this concurrency and multiple performance, you can actually do multiple tasks to be running and all that stuff. Secure. It is actually secure environment. Like security is already been considered in the design goals while designing this platform itself. Then language design goals. Like previously, what we talked about is platform design goals, and now it's we are talking about the Java language. Okay, so what did we learn today? Like Java is an object-oriented programming language, and it has a platform of its own. Right? It has a compiler, it has an interpreter, which we call it as JVM. For now, you think about interpreter is same as, like JVM is same as interpreter if you are coming from a different programming language world. Okay. So you have a compiler, you have an interpreter, and it's itself as a platform which has like bunch of design goals that it is been addressing. Okay. Then language. Let's talk about the language itself. Like language is what? It's like some way of telling the compiler what the programmer wants to do. Like okay, you have to do a task, so these are the sequence of steps in its own language that it can understand. Okay, in its own language that it can understand. We're writing it in a language, and what are the design goals when they started writing this language? It has to be simple and it has to be dynamic. That means simple to understand. It has to be dynamic. That means while during execution, it needs to accept some inputs. Okay, so I'm going to run a program today on my computer, and that is actually looking for a resource on my computer. Okay, and when actually it is running on your computer, we should be able to do the same, which is actually looking at your computer's some location. Okay, so that is what is called dynamic. Like that means while executing, we are looking at something. Right? It can be any location. Right? And distributed, like distributed is like okay, we have a bunch of systems distributed, like geographic location. Like I have one server here, one server in East Coast and all that. So though it is distributed, it should be executing in a proper way. and robust. It should not fail, for simple reasons. Like if you have a problem in your code, it should throw a compiler error, but you should not say like, oh, Ravi has written this code, I will execute only in Ravi's environment. Okay, something like that. That means it's robust. Very few times we see bugs in JDK itself. Okay, so that's actually called JDK, or the programming language itself. It should do what it said it will do. Specification said, say, okay, Java 7.x switch case will accept strings. That means it will accept strings, right? Though all these languages are written so well, you will not have bugs within the language. You will have application level programming bugs which application developer introduces, but not within the language itself. So that's what I was trying to explain. And multi-threaded. So that means, like, okay, what is multi-threading? Multi-threading is simply, okay, if you're trying to do a task, how can you improve it to make it execute in parallel? Okay, say for example, if I have a if I have to go out, I'm just throwing out an example which we have every day to day. Okay, I live in a one bedroom apartment. If I have to get ready, what happens? uh, and One bedroom and one bath. So if I have to get ready, so if we are two people, we have to do one after other. Whereas if you have two bathrooms, what happens is, like, okay, two people can do simultaneously. So that means if one after the other does, it is actually half an hour or 1 hour, right? If two people do simultaneously, it's going to be like 30 minutes each, in parallel. So in half hour, we can say like, oh, two people got ready. In the same way, you can have 10 threads running in parallel to do a task. Now you scale it up to computer world. Okay. So that's the thing. Like, okay, if you're trying to do a task, you are actually spanning n threads to, yeah, achieve the desired output in less number of time. So as a programmer, Java programmer, you should always have in mind, okay, I am doing it for one person now. If I am scaling it, and if this code is being hit multi-thread way, how is it going to behave? That's the thing. Okay, that makes it more interesting. So that's the those are the concepts that are being already been designed within the language. Okay, whereas traditional programming languages before Java, this was not being done. Okay? So that's why it's been more highlight, and they've been improving so much as well. Okay? That's the concurrency API that I'm referring to. And then interpret it. That means, okay, you compile it, and it has to run the same way. Like, it has to be interpreted the same way across the globe, across the version, across the platforms. Okay, wherever it's been installed. So it has to be interpreted. Any questions so far? If chat is not working, I'm unmuting. Okay. Okay. Cool. Fine. Okay. So Java's beginning, just to give you some background. Okay, it's called the Green Project, and name language of language of Java was called Oak before, and the company that started doing it is called First Person Inc, and they introduced something called Hard Java Browser in 1995. That's the beginning of Java. Yeah, this is not required, but just something to give you a brief background about. Okay, brief history of Java versions. Okay, so 1.0 was rolled out sometime in 94 and 95. Then immediately they did a patch, and hardly any new features. It's probably bug fixes. And then 1.1, uh, just a little more higher version of it. Then 1.2 was like, for a long time it was there. Okay, and then comes Java 2 SDK 1.3, which has like 1.4, which has like secure sockets and all the improvements in the core language. Even 1.4 was there like for quite some time, like from, yeah, till like probably 2004. Then comes Java 5 generics and annotations. These are the important concepts that we are going to learn as well. And Java 6 has some language improvements. And even 7.0 has some language improvements, not anything related to the platform. And Java 8.0 has like bunch of language, and also introduction of new features. That's so we're going to touch all these. Okay, so I advise all of you to install Java 8. Okay, um, let it give errors on your systems. We can try fixing those if you get into any errors. But I shared the link, like what needs to be downloaded and all that. But okay, so we're going to see all the features. Like Java 8 has a bunch of new features that are like lambda operator, which is similar to pointers in our traditional world. I said no pointers, but similar to pointers. Execution of it is similar to pointers. That's been actually waiting from quite some time by Java world. And Java 7, as I said, like it has something, some good improvements, like in concurrency packages. So you'll appreciate it once we go through those. But for now, this is just the brief history. And JDK is it 8 is current. Okay, and few people may ask you like what version of Java you are using. If you're trying to market yourself end of this course, you should be able to say JDK 8, and you should be able to talk to them about the new features. Okay, so those are all been covered in our courses, but to begin with, I don't want to overwhelm with all the features, but we'll go gradually on one after the other. And Java acronyms, most frequently you hear about JRE and JDK. What are all this? JRE is like Java runtime environment. This is the package that actually gives you how to run a Java program. Okay, and JDK, Java Developer Kit, it is for us. Now we are Java developers. Yeah, it is for us. Like if you write something, compiler and all that stuff is being given by JDK. And now most of the JDKs that you download come with JRE. So I just want to show and explain you what is the difference between JDK and JRE. But now without JRE, you cannot run anything. And even if you did not install Java so far, you were able to run something on browsers. Sometimes you may see in various websites like, oh, it is installing Java and stuff like that, right? Those are all JRE. Like to run a particular website, within that, if there are applets and stuff like that, they just show, oh, I need a JRE to run it. So if you don't have it, I'm going to download it and execute this program and show it to you. Okay. If you go to your command line and if you say like Java, it may still show, okay, Java hyphen version, it may still show something. That doesn't mean you have JDK, you have JRE. Okay. So that means various programs may temporarily install or may install JRE on your system, but not the JDK. You have to explicitly install JDK. And JRE is for runtime, that is for execution, and whereas JDK is a compiler, that is what we need. Okay, so we need both. We need compiling the stuff and also running the stuff. So we need both, but end users can just need JRE. Right. Java virtual machine. Okay, so this JRE has virtual machine. So I was talking about this virtual machine for quite some time. Okay, what is that virtual machine all about? It provides hardware platform specific. That means this is the one that communicates with the um, underlying hardware or the system level stuff, and reads and compiles the bytecode. Okay, so what is this bytecode all about? You have a Java program. When you say Java C, that is actually Java C is what? It is compiling the software. Okay. Once it has been compiled, it's in a bytecode. It is called bytecode. And the JVM understands only the bytecode. That means compiler is helping it to convert a Java program how the JVM can understand. Okay. This bytecode is nothing but it is an intermediary state of your source code before it is being executed. And that intermediary state is such that, okay, you can compile a Java source code in Windows, you can run it in Linux, and it will give the exact same result. Okay, so that is helping us in running it in any JVM. That means you can compile the source code and you can run it anywhere. um, I see Rini just joined. Uh, yeah, we are just discussing the fundamentals. Rini, we're just discussing the fundamentals, but yeah, um, feel free to just go through, like go with the flow right now. But once you see the slides, probably you will see like this is all fundamental stuff. I'm just going through with the like on the day one schedule. Okay. And if you have any questions, ping me. I'm muting everybody, but ping me on the chat. Okay, so let's continue. So I was at the bytecode, right? So what is the bytecode? It's an intermediary state where the source code gets compiled and it can be run on any platform or any OS, okay? And is implemented as a software. So this Java virtual machine is nothing but it's implemented as a software and comes with the Java. This is the one that communicates with the underlying system level stuff. But for us, JVM is everything. Like if you're running out of memory, that means something to do with your Java code, and it has to do with your Java memory settings, virtual memory settings. Okay, then is implemented in Java technology and Java technology and Array web browser. That means if you have JRE, like that means you have JVM as well. Okay, let's move on. So Java Virtual Machine, JVM provides definitions for the instruction set. That means CPU, and it provides the definitions for the class file format. That means if you have the bytecode and you tweaked and you changed something in it, then it cannot probably read it if it is in an unparsable format. That means it is in an unprocessable format, and it has various things like stack and heap. That means stack is where all the temporary variables are all stored. That means okay, you have executed a program like string str equals to hello world and you're trying to print that string str is going to be in a stack. Okay, that means temporary variables. And heap is where all the object creations and all that are being there. Okay, we'll talk about all that eventually, but I'm just giving a brief overview. Like you should be able to say, oh, Java virtual machine, I know what it is. It helps you in executing it. It runs the bytecode and it does all the memory management. It does the garbage collection. Okay, so you should be able to know all that. You should be able to answer all those questions. That's the idea. All right, let's move on. Okay, and bytecodes. What is this bytecode? Is all about bytecode that maintains proper type discipline from the code. And the majority of type checking is done when the code is compiled. So that means anything related to language syntax is all being checked during the compilation. And while running, it is only going to look at runtime environment. So that's why there are various error differences. While you're working, you will see like, oh, okay, it says like class not found. That means it's during the runtime, or no definition of the class found, it cannot find it during the runtime. But something like class cast exceptions and all are actually class cast exceptions are during compilation, like typecasting errors and all that are being checked during the compilation, or incompatible formats like um, you'll see that auto boxing and unboxing, like if that is not being supported, how the errors are different, all that you'll see eventually. Right now I need not say all that, but just giving you some overview. So every sun approved implementation of JVM must be able to run any complaint class file. This was the goal while they designed it. This was the goal, like anywhere, any JVM, you should be able to run the same source code, like a same compiled class can be able to run anywhere. Let's move on. Garbage collection. I was talking about this garbage collection. What is it all about? Garbage collection is nothing but allocated memory. That means when you run a program, you have some memory being allocated for that program. um, Fine, you're done with the execution of the program. That allocated memory is no longer needed. Okay, so that means it has to be deallocated. That means, so once we free it up, it can be used for some other programs, right? So all that housekeeping stuff is done by garbage collection. That process, housekeeping process, is called garbage collection within JVM. Okay, and in other languages, you do the, if you're from C++ background, you do all the deallocations and all that. Okay. And garbage collection checks for and frees memory no longer needed, and it is done automatically. Like you need not, you don't have a handle to invoke it. Okay, but the thing is, it can happen anytime. It depends on JVM implementation. All you can do is you can tell JVM, oh, please invoke garbage collection, but it's up to the JVM when it actually invokes it. Okay, there is no guarantee that because you said it's going to invoke. Okay, there is no guarantee. They don't provide that guarantee. It is going to execute at some point, but it doesn't tell us like it's not within the application programmer's control, like when it is going to do garbage collection. Okay, so this is very important question. Probably most of the people ask in the interviews, what is garbage collection, and can you actually um, invoke garbage collection, or can you guarantee that garbage collection is being executed by when you invoke it? No, you don't have a control, but you can just tell JVM, oh, please invoke garbage collection. How do you do that? System.gc, we'll see all that. System.gc, but it doesn't mean it gets executed. Please remember this, it's most important interview question. Hi. Java runtime environment, what does it do? It performs three tasks. What does it do? It loads the code. That means whatever Java code that you have written and the compiled code in the byte format, it loads it. It verifies it. That means it checks, oh, okay, is it the same as what it said it is, by loading the byte codes, and then tries to execute it. Okay, so loads the code, verifies the code, and executes the code. Okay, this loading is where if you guys are already familiar with Java, class loading and all that stuff, right, is being talked about in loading the code. Okay, then so obtaining and installing the Java, so you have this link, you got to go download it, and then run JDK and JRE. Okay, and set the path, Java home and class path, and check Java has been installed or not. Okay, so let's see. I was also hoping to do it on uh, Windows, but I'll show on Mac actually. Okay, can you see my terminal? Can you guys see my terminal? Okay, good. So how do you see if you have Java or not? Like when I say Java runtime, okay, if you type Java, you should see like something like this. Okay, that's Java. And when you say what version of Java that is installed, we are going to say Java hyphen version. Okay, so I was actually hoping to show you on Windows. You guys said you cannot see my screen, that's why I switched to Mac, and my Mac version has Java version 1.7.045, and it's a 64-bit machine, 64-bit virtual machine. Okay, fine. This is how you check whether Java is installed or not. Okay, and if you guys are on Windows, um, so download JDK, JRE, and all that, and we will talk about what is path and what is Java home and class path. Okay, and so you know how to check whether Java is installed or not. Okay, let's move on. Okay, so if you are on Windows, can you see anything in on my PC, on my system? So you're going to go to the Java folder. Okay, once you download it, you're going to go to the Java folder, and that's actually the Java home. Okay, where actually your Java is located is called Java home. Like here, if you see my this thing, okay, this is my Java home. See here, I didn't want to confuse you guys if you're not familiar with Mac. That's why this is my Java home. User bin Java. This is where my Java is located. Okay, so let's see, usr bin Java. So that's a symbolic link, looks like. Okay, let's see where else I can show. Okay, there's a symbolic link. You guys have to go to that symbolic link. That's fine. See here, library is here. Okay, Java, not Java. um where is that library I was looking for? Okay, okay, this is the library folder. This is where generally it puts in. Okay, just give me a moment. I'm just trying to see where it is. What else is there? Library is there. And okay, let's go to my hard disk. Okay, this is the library I was looking for, right? Okay, system. Okay, sorry, system, library, and then if you go here, Java. This is my Java home actually. Like here is my Java home. Okay, this was the older version I was showing. Probably 1 second. Give me. I upgraded it, right? So user bin. There's a symbolic link. Uh, library. Okay, Java. How could I miss this? Okay, see here. Okay, this is our Java home. Okay, what I'm trying to say is wherever your JDK is there, that is actually the Java home. Like your JDK version folder name is Java home. And then path. If you're talking about path, wherever your bin is there, okay, this is the path. That means if you don't give the path where your Java C is located, then your system will not know Java C. Okay, if you don't have Java installed on your local, if you type in Java C, it should say like unknown command or something like that. Okay, that means you guys have to set the path in the environmental variables. So we talked about Java home path. Path is what? Path is the location of Java C, where your Java C is there. Java C is nothing but compiler. Okay? Java home is like where actually your Java root folder is located. Okay? Then third one is nothing but class path. Class path is what? Like you can write your program anywhere, right? Say for example here on my folder, if you go here, um, let's say this is my folder, I suppose. Okay, this is all my source code, and this is my classes folder. Okay, so you got to give let your system know where your class file is. That's when it will know, otherwise it will not know. Okay, so that means class path is what? Class path is nothing but the location of your classes. That's when JVM can look for that location and it will load the class. Otherwise what happens is it cannot find the class, so it will say like class not found and all that stuff. Okay, so this is just the theory. I will show how to execute a program from scratch and all that. I was actually trying to do that on Windows, but I'll do it here for you guys as well. Java hyphen version checking, and then sample program. Say for example, hello world. Okay, let's do it here. Then probably we can talk. Okay, let me go. Let me go here. Before even doing anything here, um, let me open Notepad. Okay, say for example, hello world. Okay, so I'm just writing like how your Notepad is today. Okay, public static void main I will explain each of these steps. Okay, let's save this class in a particular location. Hello world and Java. Okay, so you have it in this particular location, and now go here. Oh, okay, it created a folder outside, huh? I didn't mean it to create outside. I wanted to create here. Okay, this here. So I'm on this location. I have this Java code. Okay. So what am I going to do? Java C hello world.java. So that means I am trying to compile this class. So it compiled. So how do I know it is compiled? So previously, if you see, like, are you guys following here? Previously, if you see, you just have hello world.java in there, and now because I compiled it, it started showing hello world.class. Okay. So that means .java file, and we have .class file. So the path where this Java .class file is there, that's called the class path. You guys have to give that in the class path. When you guys run into issues if something is not found in the class path. Okay. So let's try executing. How do you execute it? Java hello world. Okay. So it displays what we are trying to put. So Java C, name of the class, and it compiled it, and it showed us a .class file, and it when you say Java and the name of the class, it showed what is the output of it. Okay, so this is how we run the Java code. Okay, but let's go back to the source code here. Okay, so what did I do? Name of the class hello world, and I said public here. What does that public mean? That means it is available for everyone. Public means available for everyone. These are all part of encapsulation. We'll talk about it during encapsulation, but I'm just trying to tell you, when you're learning from scratch, look at what I'm writing on our basic class. Okay, so the structure is going to be similar for all the classes that you're going to write subsequently. But okay, before you even start about this, what is a class? Class is nothing but a prototype or a template. Okay, template that you're providing it to JVM. That okay, so I have something called hello world, and this is the template. This is how it looks at like. What, how is it? How does it look like? Hello world is the class, and it has a method by name public static void main. Okay, so that means the template that you're providing has this one method. This public static void main is method. Okay, for today, just follow this part. Once we are into object oriented OOPS concepts, we'll talk more about it. Okay, that means class is a template. What does this template has? It has one method. Fine. And we set public here. That means it is available for everyone. Okay. There are rules around it. Here, if you look at the name of the class, hello world. And if you look at the name of the file, same, right? I gave hello world.java, right? That means Java allows, somebody has a question? Okay. Oh, okay. Fine. So Java allows only one public class, only one public class per file. That means in the same hello world.java, you can have more than one class, more than one template defined, but there can only be one public class. Following my point? You cannot say two classes. That means you cannot say one more public class, hello world 1. Okay? Within this. When I say that, what happens? See, see here. Class hello world 1 is public and should be declared in a file named hello world 1.java. That means you should have only one public class per file. Okay, anything that is public should be defined in its own file with the same name. Okay, fine. For now, let's move forward. What are we trying to say here? Public static void main string args. You can ask, if you have ever written Java certification, you know it already. Like, you can ask 10 different questions on just this particular thing, like public static void main string args. What does it mean? Okay, so public means this method should be available for everyone who has access to this class. Fine. Static. Static means you don't need to create an object of this class. Fine. Void. It doesn't return anything. Main is the name of the method. And what are these arguments doing? Okay. String args. That means if you were to pass some parameter to it. Okay. If you were to pass some parameter to it like this, that means if I execute and pass Ravi, it should say hello world Ravi. If somebody else tries to execute it and pass Nukala, it should say hello world Nukala. So that means during runtime, it has to accept some parameters, okay, arguments. Those arguments are being captured in this string args. Okay, let's see. I'm going to compile it. I'm going to say Java hello world Ravi. Okay, it says hello world Ravi. And if I say, says like that. Okay, so this is all been captured in this string args. Fine. Okay, so that means we know how to declare a method in a class. Fine. So that means it is executing this main method. It is getting displayed means what? It is getting executed. So public static void main is the first method that gets invoked in a particular class without even creating a object of that class. Okay, object means we'll talk about it, but right now we did not create any objects of it. Fine, it executed this method. Good. And in this, how do we know these three? It is just to get used to the syntax. This is the name of the class, and within this class we have this method called dot out, and within that we have something called println. Okay, you can ask me a question. How do I know all this? Right? How do you remember all this? Because I'm doing it every day? No, it's not just that. You can go to, even you can know everything about it. Okay, if you are using Java 8 API. Okay, so it's been defined everywhere. It's been defined here. Like, what are the list of classes that you have? What are the list of these are the packages, and what are the list of classes you have, and what are the methods within that? Okay, by default, if you see here, I did not declare any package here, right? So all those are part of java.lang.package. Anything that is part of java.lang package, you need not do an import, explicit import. We'll talk about all that later. But I'm just giving you a little bit context here. How do we remember? Okay, I'm in java.lang package. I'm going to system class. Okay, system class has what? it has out as a parameter, out as a method. Go ahead and search here. Okay, see, system dot, it has a static variable by name out. That's why when it is static, I need not create an object here again. I just say name of the class dot out. It is a static variable, and within that static variable, print stream. Okay, if you go to the print stream class, what are the methods it has? It has these methods. And what is that we are using? Println. Okay, println. Okay, so that's how you will know what method, like how to use and what are the methods within each of it. Okay, this is about when you are writing it in a notepad. If you are using editors like this, like if you are using editors like this, these are called Eclipse, that is like a IDE, like integrated development environment. This is where you're going to be working on if you start your work. And okay, so here, so this is where you're going to write everything and run your programs. And when you do that, what I want to show is it will show all the methods based on the language specification. You need not remember those. You can just say control space and everything will be displayed. Okay, that's what I'm trying to show you. Let it launch. Okay, it's saving my workspace. That's okay. Let it launch. Okay, now that you got a background of like how a Java program is being executed, what does it do? You can compile a Java code. It We converted it to .java to .class. Now when you're running it, okay, let it do it. So when you're running it, class loader is reading the bytecode, that means .class file. And what does it do? It uses the interpreter and during executes it. Okay, interpreter executes it using the runtime environment, runtime packages, using the hardware support if required, and displays the output. That means JRE does loading, verifying, and executing. How does it verify? By using the bytecode verifier. That means it loaded the bytecode and it verified it and then executed it. And the code generator during runtime is called just-in-time code generator. That means, okay, based on what is there in the bytecode, it is generating the code, looking at it, and that is called code generator. Okay. Okay. So what is an IDE? IDE is an integrated development environment. Why is it being used? Anything that are developer tools should help his productivity to be increased, right? So if I am writing it here, I had to write all this from scratch. But whereas if I'm writing something in here, like you guys also will install it slowly, like today, by end of today. Okay, I do the same project here. Okay, I say Java project. Ah, day 1. Okay, it is asking me what JRE to be used and all that. Even if I don't look at all that, click on next and finish. It's going to create everything for me. See here, it's going to create all this. Okay, now what I'm going to do, I'm going to create a class hello world. Okay, and I say I need a public static void main and all that. See here, it created everything for us. So that means IDEs are used for improving the developer's productivity. So now if I do system dot out dot println, it is showing everything. Okay, so that means you need not remember anything. All you need to know is, okay, there is something in that particular class. Then you can look at it. You can look at the Java docs and start using it. Okay, so now that I created this, I'm going to say, okay, run as Java application. It is going to show it here. So that means integrated development environment. Everything is here, which actually improves our productivity rather than writing it on here. Here it is all error prone, right? I can do some mistakes and all that. Here, if you do a mistake like this, it's going to alert us. So This is where we spend most of our life in IDE. It need not just be Eclipse. You guys might have used different IDEs before, but I am using Eclipse for this course, and it is widely being used. Okay? Fine. So this is the advantage. So what did we see? What is an IDE? Why is it used to improve the productivity? And what is Eclipse? And this is the link to download Eclipse. Okay, I'm going to send this deck to you anyways. Okay, so demo how to create a hello world. We did this already. Okay, any questions so far? Are we following? Anybody around? Okay, okay, cool, fine. Assignment. Everybody have to install and run Java program before our next session. Like I used to do daily sessions, that's why it is probably said like, oh, before next session, but we may spend some more time a little bit. Hmm, we may spend some more time, but so okay, everybody have to have it up and running tomorrow, and if you run into any issues, you guys have to stop me right then and there and tell me like, oh, I cannot run it, and I'm going to help you by sharing the screen so others can also see your screen, and probably we all can debug issues and all that. But if you don't run it, if you don't install it, we're not going to continue. Okay, because this is, once you have your environment set up, then you can explore a little bit, otherwise it's of no use, right? Cool. And I know Rini mentioned she has a problem already before. If you are already cleared with your problem, fine. Otherwise, I'm happy to assist tomorrow when we are addressing for others as well. Okay. Um, okay. So you're going to install it today and run it. Okay. This is the like I need to change this deck like saying like week wise, but that's fine. So our objectives were today like this, right? Objective was okay, learn what is Java and why it is being used. All this we discussed. What is JDK, JRE, path, class path, JVM? Any of these sound? Any of these ring a bell, or all this is still confusing? If you have any of the question, this is the time to ask because I'm going to move forward. If you none of you have any questions here, okay, set up the environment, JDK, JRE, and where to install. I'm going to send these slides as a Google Doc. Probably you guys can uh, follow that. So if you are clear on class path and all that, that's it. I'm not going to talk about it in the coming classes. I'm just going to say, oh, this is not in class path, that's all. You guys have to probably connect to it back. Okay. Mm, fine. So if none of you have questions, let's move forward with the tomorrow stuff. Okay, that's second step. Okay, just bear with me for one more minute. Okay. Interesting. This is okay. Let's start with language specifications. And if you go back to our schedule thing, okay. Learn to implement programs using various data types and arrays. Take command line arguments, loop through them, use various operators in a class. Okay. And identifiers in Java, operators, and all that. Okay. So we're going to look at all this today. So Java language specifications. Summarize. Okay. Know various identifiers and data types and constants in Java. What are all these? And should be able to write program using different data types and operators by end of this course. Class should be in a position to execute the exercise problems in the end and their own. Okay, so let's see what it is. Okay, so programs that examine data, like we have already seen what we can print text on the screen. Okay, how we can print it, we just saw. Now we will learn how to manipulate other kinds of data. Like, okay, I print out 42, which is like a number, and then I want to do some math manipulation, like multiplications and all that stuff. How we can do it? So if you execute these three steps, you can actually do it. And data, what is data? Okay, um, it can be numbers, characters, or other values that are processed by a human or a computer. Okay, useful computer programs manipulate data. So all we try to do is deal with the data in any of these programming. Okay. Uh, three permissible styles. What are these comments? Comments are actually very helpful when to maintain the code. Okay, so if you look at it here, if I just write it like this, like this is a simple logic, right? Simple thing, so everybody can follow it and all that. Yeah. but but if you want to know like who has written this code, or like, okay, what is this method used for? Okay, what is this method used for? These are called Java docs actually. Okay, so this is all inbuilt Java docs. But if you want to tell people like why you had to do it this way, okay, there can be n different ways of doing stuff, right? So if you want to share with the team or whoever is maintaining the code that this is used for something, okay, purpose of it, then we use this comments. And there are three styles of comments that we follow here. One is commenting one line, commenting one or more lines, and documenting the comment. This is actually similar to what we did here, right? Documenting the comment, like similar to Java docs. Okay. Fine. Okay. Semicolons, blocks, and white spaces. What is it? A statement is a single line of code terminated by a semicolon. If you see our program in here, everything, like every line has a semicolon. Like within the program, within the method, every line should end with a semicolon. That's actually the language specification. And what is a block? Semicolon, we know, like if any statement should be terminated by it. And a block, any block, we put it in a curly braces like this. Okay, parenthesis. A block is a collection of statements bounded by opening and closing braces. Okay, here, if, okay, so if you were to do something, you put it in this block. A block can be used in a class definition. This is what we did in a class also. Okay, so this is all a block if you consider it as a class, and this is all a block if you consider within a method. Okay, this is all a block if you consider within a condition. Okay, if you were to do something, I'm just giving an example. Okay, so this is all a block. Okay. Fine, let's move on. Any amount of white space is allowed. Java program doesn't care even if you have like 10 lines in between or whatever. It doesn't care like this. You can have any number of white spaces. It ignores all those. Identifiers. What are identifiers? Identifiers are the names given to a variable, class, or method. Okay, can start with a letter, an underscore, or a dollar sign. Okay, so all these are variables. Variables are nothing but like this. So for example, these are all identifiers that we are talking about. That means names that we give. The name can be for a method, the name can be for a class, and the name can be for a variable. So this is the class we saw, and this is the method we saw. And what is the variable? Say for example, int I equal to 0, and I'm actually printing value of I is. So this this is called a variable. Okay, this is a variable within this method. Okay, so this is called variable. And the name that we gave here is I. You can give anything, anything. Okay, like this. You can give any number of variables. Data types. Most programming language like Java have a notion of data types and ask the programmer to specify what type of data is being manipulated. Data type. So here, this is variable we talked about. And int access DDS is nothing but data type. This variable is of data type int. And what are the various kinds of data types? We'll look at it. But to know, I just randomly gave, okay, int. That's the type. You always need to specify what the type of that variable is, right? So type, a category or a set of default values. So integer, real number. So why do we use it? Because default there is a value for it. If you don't declare it, it specifies it as 0. It assumes it as 0. But here it may complain saying like, okay, may never been initialized, but within programming, within programming, um, like uh, like this. So it needs to be initialized always. Or if you don't initialize it, what I'm trying to do here is access DDS equals to DDS plus 1. Still it says it is not initialized. So you have to always initialize it. And the thing is, default value for it is 0. But compiler doesn't allow it. You have to always explicitly initialize it. And also it's not a good practice to use variables with which are not being initialized. Okay, so that's the thing. If you specify a data type, default value is assumed sometimes but not always. Okay, fine. Internally the computer stores all the data as zeros and ones. It knows only the binary data, right? So if you say 42, internally it is the binary representation of 42. And if you say hi, it has some other value. Okay, um, so internally it knows only this. So that's why if you specify what is the type of that variable, it knows how to convert it, like whether to take 8 bits or 16 bits or 32 bits. Based on that, computer will generate some value corresponding to it and store it. Okay, that's why you need to specify the type. Primitive types. So Java programming language defines 8 primitive types. One is boolean, character if it is a textual value, byte, short, int, long, and if it is a real number like a decimal pointer, you can use double or float. How exactly each of these are different? Logical is if you want to do something like if and else. Okay, textual is like if you are using characters, unicode characters and all that. And if you are using integer, if you know you're going to use only the 8 bits, you're going to use byte. If you know if you're going to use more than 8 bits, you're going to use short. If you know you're going to use 32 bits, 32 bit, it's int. Okay, long is 64. And again in decimal pointers, float is 32 and double is 64. Okay, but uh, in terms of integer, int is default. Like most of the people widely use int, unless who is really concerned about performance and who is really concerned upfront while writing the code itself, they use byte and short. Or default people use long, just to be safer side. If you want to grow tomorrow and need not go back and change the code, people use long. That's okay, it doesn't matter actually. Fine. So these are the various types, primitive types. So if somebody asks you what are the primitive types of primitive data types, you should be able to talk about these. Okay, fine. Logical. So these are few slides that talk about how to use it. The Boolean data type has two literals, true and false. For example, the statement Boolean truth equals to true declares the variable truth as Boolean type and assigns it a value of true. Then textual char and string. What is this char? Represents a 16-bit Unicode character and must have its literal enclosed in this quotes. Okay, uses the following notations. Quote. This is how it is being displayed. And string str, I said, right? Like it's not a primitive data type. It is not one of the primitive data types, but it is a class in Java. String is a class and has its literal enclosed in double quotes. What is the difference between char has single quotes, string has double quotes. Okay, the quick brown box fox jumped out over the lazy dog. So this is kind of string. Okay, and if you want to display it, you have to put it in double quotes and display it. Then integral, byte, short, int, and long. How are these different? So uses three forms: decimal, octal, or hexadecimal. Okay, so the decimal value is 2, and the leading 0 indicates an octal value, and the leading 0 to x indicates a hexadecimal value. Okay, so each of these values can be represented in various formats. That's the thing they were talking about. Like numbers can be represented in decimal value or no 0 decimal, or it can be represented, a number can be represented in an octadecimal value, or it can be represented in a hexadecimal value. So you should be able to convert um, octadecimal to decimal and hexadecimal to decimal and all that stuff. But internally, even if you don't know that, if you give a hexadecimal value, computer can convert it to corresponding values. Okay, and has a default is int and defines long by using L or L. So you should be able to always say, okay, long s equals to, if you just say 2, it doesn't know, it consider it as integer. So if you want it to be considered as long, you should say 2L, either lowercase or uppercase. Okay, default is considered as int. That is what they are trying to say. And another thing is, okay, if you want to do like what, no, like I was talking about ranges, right? It is 8-bit, byte is 8-bit, and what will be the range if it is a bit? Minus 2 power n minus 1, which is 7, to 2 power n minus 1, that means minus 128 to plus 127. That's the range. Okay, in a similar way, for this one short, it is minus 2 power n minus 1, which is 15, to 2 power n minus 1 minus 1, which is 2 power 15, and again you do one more minus 1. So this is how you define, okay, if a particular variable's value, like if a particular variable's value goes beyond this range, then you choose that particular data type accordingly. Are you guys following so far? Okay, so that's how you got to determine. Okay, fine, let's move forward. Floating point and float and double. Default is double. Okay, so if you are defining a float value, you got to explicitly say small f or capital F. Okay, fine. Floating point literal includes either a decimal point or one of the following. Okay, so a simple floating point value is 3.14. A large floating point value is something like 6.02 into 10 power 23. And how do you say into 10 power 23? E23, like that. Okay, so a large double value is big. Default is double, right? So it will default consider it as double. You need not specify a d there. Okay, fine. What are the like float is 32 bits and double is 64 bits. Okay, fine. Java coding conventions. classes, class, and then here this is called actually camel case. This is called type case actually, like a class, um, account book. First letter of each noun is actually in uppercase. Okay. Class, complex variable, like I need not say noun, but it can be like each word, just remember it like that. Okay. Class, account book, class, complex variable. Okay. And interface is also the same as class, whereas methods are camel cased. Okay. That means first letter of any method will be in the lower case, first letter of the word will be lowercase, and subsequent words will be with followed with uppercase first letter. That means balance, account. This is called camel case. Okay. And name of the class is called type case, I think. Okay. Just follow this conversion. It took so long for me to understand when I first started. Why are you guys writing in different ways and all that? Okay. But this is the thing, that's why I put in this slide. If you are very new, just remember this. Okay. If it is if it is a different word, first letter of it on the class will be always uppercase. You can ask me, oh, if I give a lowercase, it doesn't take it. It will take it, but it's not a good coding practice. Okay. People are used to it now. Okay. Java coding conventions. Variables also the same as methods. Method naming convention. And constants. What are these constant values? We cannot change those values. If you know some values will not be changed, say for example pi, we know it's 22 by 7, right? So those kind of values we take it as constant, and those values will not be changed at all unless you do some truncating and all that stuff. But so see here, head count, max size. That means if you know a particular value has a max size and which is fixed, you're going to use constants. Otherwise, if you know if it is been changing, we are going to use variables. Okay. Operators. There are various types of operators, like arithmetic operators to do some arithmetic operations, bitwise operators to do some like whether it is true or false, or if you want to modify the bit, like if you want to shift bits, like it's 8 bits, I suppose. If you want to shift something to left or shift something to right, those are left shift and right shift operators are all part of bitwise operators. Relational operators like greater than, less than, and all that. Boolean logical operators. You know what Boolean operators are. And then short circuit and assignment operators. Short circuit operator is nothing but it's just that OR conditions, I suppose. Okay, if you use a short circuit OR, it's going to evaluate the right hand side, like like say suppose OR. If you take OR, if both are true, then only it will be true, right? If first condition itself is true, it need not execute the right hand side of OR. Like OR means either or, like either first one or second one is true, right? If first one is true, it need not execute the second one. Whereas and say suppose if first one itself is false, then it need not execute the right hand side, right? So that's the implementation in short circuits. We will see the implementation, but I just want to give a heads up. Ternary operator. So it's another form of if like if and else. Okay. You can just put a question mark. It's a syntactic thing, no biggie. Okay. Let's see. Expression. A data value or a set of operations that compute the
Ravi,
data value. Say that again.
yeah, Ravi, there's
Yeah.
a question.
Yeah.
For short circuit operator, in that means
I cannot really hear you. You got to be really come closer to your mic, probably.
okay. Ravi,
Yeah.
if you're seeing an expression, just you are showing us on one expression page, right?
Right.
1 plus 4 into 3.
Right.
So short circuit operator means we will do first 4 into 3, then plus 1, right? You're saying this?
No, no, no. I'm not. I'm not saying that. That is done actually. If you look at the slides,
Okay.
operators, I just gave a briefing of operators. Short circuit operator, I just mentioned a little bit about it, and it's a new slide. It has nothing to do with the short circuit.
No, no. Yeah, I got it. You said short circuit operator operates from right hand side, right?
I did not say that. I
Mm.
said short circuit operators, if it is an OR, it operates on left hand side, and if OR left hand side OR is itself is true, then it need not execute the right hand side. Okay, let me put
Okay.
it on the code, then you will probably feel much better here. Okay, so here is the thing. If two, not true, okay, boolean 1 equals true, boolean 2 equals to false. Okay, okay, if I do this, 1 is there, right? If 1 itself is true, it need not evaluate this. Okay, and and okay, if 1 itself is false, it need not execute this because it's already false.
Okay.
That's what I'm trying to say.
Okay. Got it.
Okay, yeah,
Thank you.
yeah, okay, so let's move forward. Expression, a data value or a set of operations that compute a data value. It's called an expression. So that means a variable v equals to, we can say, like 1 plus 4 times 3. What's the value of it? 13, right? It's going to execute the right hand side multiplication first and then going to do 1. Okay, so that's how these expressions are written. That means you're going to evaluate value and then set it to the left hand side. The simplest expression is literal value. A more complex expressions can have operators, parentheses, and these operators are called operands. Okay, values of these operators are called operands. Fine. 5 common arithmetic operators we use are addition, subtraction, multiplication, division, and modulus. Okay, addition, you guys know, negation, and multiplication, division. Modulus is actually going to give us the remainder, whereas division is going to give us the quotient. Okay, fine. Let's move on. Evaluating expressions. When your Java program executes and encounters a line with an expression, the expression is evaluated and its value is computed. So the expression 3 times 4 is evaluated to obtain 12, like this. Okay, not 3 times 4, like that means 3 into 4 will not be displayed like this. It gets evaluated and displayed. But you can ask me a question. Oh, okay. How can I display 3 times 4 alone? No, I don't want it to be evaluated, right? Let's see what this will return. It returned 12, right? So if you just want to display 3 times 4, you are going to do like this as a string. Then it doesn't get evaluated. Yeah, that's how you do it. Okay. Then it is treating it as string. It is not treating it as expression. That's what I'm trying to explain. If you do it this way, it says 3 times 4 into, okay, So this is just be careful and see how it is getting displayed and get familiar with it. Right. When an expression contains more than one operator of the same kind, it is evaluated left to right. Okay, that means 1 plus 2 plus 3. Yeah, it is evaluated from left to right. So 1 minus 2 minus 3 is 1 minus 2, then minus 3. Okay, and not same as 1 minus 2 minus 3. Okay, so just be careful. It is going to be left to right if it is the same kind of operator. Okay, so these things may not matter that much in phone interviews, but if you are actually attending physically, people may take you to a ride if you are confused on this. So probably brush up everything, try all possible combinations, okay, which are being mentioned in these slides, and be confident. Okay, left to right, right to left, you may get really confused in the interviews particularly. Okay. Division. Okay, 4 by 4 evaluates to 3, not 3.5. Why? That's because it is constrained. You are dividing it by an integer. So it thinks when you are dividing it by integer, it thinks you are expecting an integer to be returned back. Instead, if you divide it by 14 by 4.0, sorry, 14 by 4.0, then it returns a 3.5. Okay, that's the difference. I think it's same in any programming language, but I'm just giving you some examples where I felt I need to mention. Okay. Mm, that's how it is. And try all kinds of examples that are mentioned here. And dividing by zero is going to crash your system, like crash your program. It's actually infinity, right? So it's going to crash your program, like number format exception or something. Integer reminder with percentage. Like if you do modulus operator 14 by 4, it's going to return the remainder instead of the quotient. Yeah. Try all these once you got started. Operator precedence. How does Java evaluate 1 plus 3 times? Previously we saw this, right? We were thinking it's going to return it's going to return 13. I said it's going to return 13. How? Let's see. Is it 1 plus 3 times 4 or 1 plus 3 times 4? It's like 1 plus 3 times 4. Okay. In a complex expression with several operators, Java uses internal rules of precedence to decide the order in which to apply the operators. Order in which operations are computed in an expression. Yeah, multiplicative operators have a higher value. I think you guys must have seen this bod mass also, right? But it doesn't exactly follow that. But yeah, if you follow that, you can get most of the times right. Okay. So multiplicative operators have a higher level of precedence. So in our example here, 3 times 4 is evaluated first and then added to 1. So that's why it is 13. So if you use a parenthesis, then it is going to be 16 because 1 plus 3 is 4, 4 times 4 is 16. Okay, so just be careful and look at the expression more carefully. Okay, precedence examples. Okay, so just just to give an overview. Okay, let's see this. So if you are doing 1 into 2 plus 3 into 5, what does it do? So these two take precedence, these two take precedence. So one, these two are evaluated, and then these two are evaluated. Okay, that's how it's going to be. Okay, so that's how it is deriving it as like what 15 plus 2, right? So that's how it is evaluating the values. Okay, and here what is it doing on the right hand side? 1 plus 2 divided by 3 times 5 minus 4. So 2 by 3 is being evaluated and then multiplied by 5. Okay, so that's how it's going to be. And then it okay, just follow these, go through. These are simple to understand, simple math, not even programming yet. Okay, Precedence examples. What values result from the following? So this is an exam exercise for you. Like you got to implement all this, and you should know as well like how it is behaving, right? And now a question to you guys is like which parentheses above are unnecessary, which do not change the order of evaluation. Okay, which of these do not change the order of evaluation? We know left to right, and if it is the same operator, it doesn't change the order of evaluation. But which of these have a parenthesis which is unnecessary? Parenthesis, if you are going through elimination route, only this or this has a parenthesis, right? Which of the above parentheses is unnecessary? So probably this one is required. Otherwise, it's going to do something else, right? It's going to do what? -8. I think probably this one 18 mod 7 takes precedence. Otherwise, if this parenthesis, I think this parenthesis, they were talking about this parenthesis. Okay, let's see. Ah, there is no answer, but yeah, this is just I gave the answer already. I think this is the one. Do you guys agree? Like this is addition, and here we have modulus. So 17 minus 2, this parenthesis I'm talking about. Okay, outer parenthesis doesn't change the order of execution. It's unnecessary, right? Are you following, or do you have any question? Are we here? Yeah. Okay. So real numbers. The expressions we have seen so far used integers, right? But Java also can manipulate real numbers. So the operators we saw as well as parentheses all work for real numbers as well. The division operator produces an exact answer when used as a real number. Say for example, previously I mentioned, right? 15.0 by 2.0 is 7.5. If you just do a division by 2, it's going to give 7. Okay? Yeah. So the same rules of precedence that apply to integers also apply to the real numbers. Okay. There is some real number example also probably. Yeah. Go through this. Okay. All right. Let's move on. Strange things are afoot with the real numbers. So here, if you just add it up, the mathematically correct answer should be 23.1. See here, but it gave us 23.0. So it can be something to do with the truncations within it. If you do um, if you do one decimal, it's going to be 23.1 itself. But here it is giving us more accurate value. So you got to truncate it to one decimal to get the right value. But that's okay. It's like more appropriate. Yeah. It's not incorrect, but it's giving the exact decimal values here. And you can set the precision, like you can scale it down to 1 and all that using big decimal. We can talk about it later. Mixing integers and reals. When Java operator is used on an integer and a real number, the result is a real number. See here. So we are multiplying it by real number, so it gets real number. When you're adding it by real number, you get an real number. Okay. So just remember this. Otherwise, it's going to be like if you are dividing by integer, it's going to be an integer. But if you are multiplying and adding, it's going to be a real number. Variable. A piece of your computer's memory. What is a variable? A piece of your computer's memory that is given a name and type and can store a value is called a variable. That's what we did, right? A piece of computer, we gave a variable name here and all that previously. Remember? Yeah, a variable name that can store a value. Okay. So we use variables to store the results of the computation and use those results later in our program. So unlike a cheap calculator, which may only have enough to store few values, and we can declare as many variables as we want in the computer. Mm. Variables are a bit like the 6 preset stations on your car stereo. except we can have many of them as we want. Like they are all preset and we give some value to that, and during execution you can modify those values and all that. This is just an analogy that I want to give. Okay? Fine. More on declaring variables. How do you want to declare the variables? Declaring a variable sets aside a chunk of memory in which you can store a value, int x, int y. Crude diagram of the part of your computer's memory is x and y. Okay, like this. This is how it gets reserved. That means because it is int, it is 32-bit. Okay, but uh, it is reserving in a crude way, but it doesn't have a value yet. So the compiler will fail if you try to declare a variable twice. Okay, so here it reserved a memory. Okay, but it did not set a value to it yet. Okay, and if you declare duplicate variables, it says that variable is already been taken. Assignment statements. How do you assign values to it? So you're just going to say equal, right? So that's just, yeah. More about assignment. The value assigned to a variable can be complex expression. The expression will be evaluated and the variables will store the result. Okay, so even if this complex statement is there, the variable of the like ultimately it gets evaluated and gets set to the value. Okay? A variable can be assigned a value more than once in the program. Okay, so it can have 3 here, and it here the value gets bumped up based on that expression. Once a variable has been assigned a value, it can be used in an expression. Okay? So in text, and it is assigned a value, then you can start. Otherwise, it says like it is not initialized. We saw that, right? Yeah. So the above has output equivalent to this one because it replaced x with 3. That's the value of it. Okay, fine. Variable has not been assigned a value cannot be used in an expression or a println statement. We saw these errors already. Assignment and algebra. Though the assignment statement uses the equals character, it is not like an algebraic equation. Equals means store the value on the right into the memory of the variable on the left. Okay, so if it is a variable x, then this is true. If it is a number, you cannot do this. If you are trying to evaluate this value, you have to put double equals. Okay, single equals is nothing but assignment operator, and you can do assignments only for variables. You cannot assign for constants or numbers. Okay, fine. What do you suppose happens when a variable is used on both sides of an assignment statement? X equals to 3, x equal to x plus 2. Do you guys think it is valid? Can anybody with some programming background, or no need of programming language for this, I think. Will it throw an error if we do this? They just says no. Anybody else? Yeah. Soumi also says no. And Brinda, do you want to say yes? Yeah. Okay. You guys are all aware of it. Yeah. Okay, go ahead. Yeah, it doesn't say anything. It's fine. It's just in equal x equals to 3 plus 2 equivalent to. Fine. Assignment and types. A variable can only store a value of its own type. That means if you say int x and x equals to 2.5, it throws errors because it doesn't know what decimal is. It is all integer value. Okay. Technically, the value does not need to be the same type as the variable. It can be any type that Java knows how to convert it into. Yeah. So here is the thing. Double, if you say 4, my GPA will have like 4.0. Like if you're saying double, like an int value can be stored in a double. It again depends on the hierarchy of it. Like right now with the latest versions of Java, You don't need to worry about all this because there is a concept called auto boxing and unboxing. What is it? It's like auto boxing is nothing but integer is a lower bit number, right? 32 bit, and long is a higher bit, 64 bit. Previously, if you were to typecast a long value to a integer value, you're going to lose some bits, right? Because from 64 bit you're coming down to 32 bit. You got to explicitly cast that and all that stuff. So that's when we used to get some errors and all. And it is illegal if you don't typecast it to like an long value without integer value. If you don't typecast it, it never used to convert to int. Now with auto boxing and unboxing, it can always convert those values. Okay, so that's why right now you guys need not worry about all this stuff that we are talking about. It's all been taken care of now with the latest version of Java. Okay, so if you declare it, it will assume default like okay, if it is double it's going to say 4.0. Okay, but not the other way around. If you say int and say 4.0, it's going to complain. Okay, that's how it is, that's how it goes. Now with auto boxing and unboxing, all these are being taken care. So what is the output of the following Java code? You guys can take a look at this. I'm not going to talk about it now. Okay. Yeah, feel free to ask me any questions if you run into problems while executing. But please do execute all these before next class. That means not tomorrow, but next week probably. Declaration and initialization. A variable can be declared and assigned an initial value in the same statement to save lines in your code. So all these you will get it during coding styles, but just want to make sure you can also do this like int a equals to 2, b equals to 3, and c equals to 4, all the stuff. Okay, so multiple declaration errors. That means yeah, if you do it, variable already exists, you know this already. Yeah. Strings in the expressions. Say suppose a string can be used in an expression, but only operator strings understand is plus, that is concatenation. If it is plus between numbers, it's actually addition, but here it is concatenation. And a plus operator on a string and another string causes the other value to be attached to the string. Right? So here is the thing: hello plus 42, it is hello 42. That's how it is actually concatenating. The precedence of plus operator is below. Okay, so here is the thing. We can just take a look at it. Fine. So one, this is not going to add, but it's going to concatenate here. That's what I'm trying to make sure here. Okay. Okay. Printing string values. You are going to put it in system.out.println to print the values. Example variable exercise. Okay. Write a Java program that stores the following data. Section A has 17 students. AB has this. Average number of students per section. You got to determine average number of students. This is an exercise for you guys. Okay. Then modify and assign operators. Okay, so here is the thing: Java has several shortcut operators that allow you to quickly modify a variable value. Like any variable plus equals means it is same as saying like variable equals to variable plus value. We saw that, right? And variable equals variable minus, so it's same as any other programming language you guys are aware of. Yeah. And yeah, this is what I was trying to say. Okay. Then increment and decrement. You can just say shorthand operator like plus plus, or you can do plus one or minus one. Okay. So system.out.println command. We talked about it already, right? Like Java has another command called print. So what is the difference between system.out.println and print? Println is going to make sure any subsequent system.out.println, um, like what it is going to do is it's always going to print it in the new line, whereas print is not going to print it in the new line. See here, kind of like a cloud, I was up here, and it's going to make sure anything that is followed by it, like here, anything that is followed by it is in a new line. See here. So kind of like a cloud. I was up, and anything after that it puts the new line feed. So any subsequent system.print will be in the new line. But if you put another system.out println after the last line, it's going to print in the same line. Okay, that's the thing. It's just going to add the ln feed in the new line feed in the end. Okay, logical operators. Boolean operators are supported as not. You guys know this already, right? Not is in this, and, or, and XOR, exclusive OR. So bitwise operators are complement, XOR, like these are like the first ones are Boolean operators. Like that means we are going to do those. Um, we're going to use those between two variables and all that stuff. But here, bitwise operators are like in between the bits, like in between two integers. Say suppose those are represented in bits, and if you are going to do a complement, it's going to do the opposite, like logic gates. Like if you are from electronics background, if you have like bits, two different bit representations, we're going to do operators on top of it, like complement, which is like opposite of these two bits, whereas or, exclusive or, and similar, those are all supported in Java as well. We don't use that much. I did not get a chance to use as well till now, but just to let you know, these are there. Okay. And but if you're preparing for sun certification, you will have a lot of questions around this, like what is the value of it, complement, and idea is they want to make sure you are aware of the operator. So any number represented in a bitwise bits, and then do perform the operation and evaluate the value out of it. Short circuit logical operators, we saw that already, right? The operators are and are. Yeah. So short circuit, if this is true already, if this is itself is false, it will not go here, because and is both should be true. If it is or, either one of it is true, then it will not go to the next one. Right shift operator, these are the bitwise operators. So right shift operators and left shift operators here. So see here, 128, right shift 1. That means when you're doing something like a right shift, it is like dividing it by that number. Okay. 128 is represented in bit format. Okay, like how do you do that? You do the prime factorization, right? Like do you guys see my this thing here right now? Okay, let me just put it here. 128, how are we going to write it here? Like 0 0, like 2 power 7, right? 2 power 7 is 128. So I'm going to put zeros here, 3 4 5. Like first location from the right is 0 1 2 3 4 5 6, right? 1 8. So this is an 8 bit, right? So 0 1 2 3 4 5 6 7 8. So everything is represented as 2 power something, right? So this is seventh location, so 2 power 7. Okay. When you're doing a right shift, that means you're trying to make it to 0 0 1, like this, right? So idea is you're moving it to right, that means you're making it like 2 power 6. So 2 power 7 divided by 2. Right shift is what? You're dividing by 2, which is 2 power 6, right? So that's what, yeah, we are trying to arrive at. Okay? That's what we are trying to arrive at. So if you're doing a right shift, you're dividing by 2. If you're doing a left shift, you're multiplying by 2. Agree? You guys are aware of it already, or following it? Any questions on this? Okay. So logical or unsigned right shift operator. So unsigned right shift is like when you do a right shift, um, so like you may have sign, like you may have to maintain the sign of it. Okay, if it is minus or plus and all that. If it is unsigned right shift, like you're not going to maintain any sign there. Okay, so used for bit patterns, not copied during the shift. So logical or unsigned right shift operators. These are actually doesn't carry the sign. I mentioned it, right? Okay, yeah. Fine. Left shift operators, we saw that already. Okay. Double equals operator versus equals operators. This is a very, very important interview question. Okay. Difference between double equals and equals. Double equals determines if the reference values refer to the same object. That means if x equals to 2 and also x equals to like y equal to x, okay, int x equals to 2 and y equal to x, then if you say y equal to x, okay, that's equals because they both are referring to the same value, right? Or if you say x equals to 2 and y equals to 2, x equal to y, that is also true because both have the same value, reference value. Whereas if you are talking about it in an object oriented world, string x equals to Ravi, okay, and string str2 equals to um, something else like string str2 equals to again new Ravi. Okay, let me put it here, otherwise it's confusing. Okay, string str1 equals to new string of, okay, Ravi, right? And string str2 equals to new string of Ravi. Okay, if str1 equals to str2, let's execute this and see what it is written. It's not returning anything. See here. See, it's not entering this. Okay, why? Though you expect this is also Ravi and this is also Ravi, why it is not equal? Because double equals only looks at reference values. That means, so that means, see, entered the condition. You see what I'm saying now? So what it is doing is string str1 Ravi. So this is actually considered as a value of a variable. Whereas when you are talking about objects here, I will tell you what a constructor is, object is in the coming classes, but just listen to it for now. So when you're creating an objects of a str1 and str2, these two are two different objects. That means these two are referring to two different memory locations. Okay, in JVM, if you see and understand it here like this, str1 is a memory 1 location, str2 is at memory location 2, and it has all it is checking is value at memory location, value at memory location. Okay, if it is just this, if you just say it like this, both have memory location value as Ravi, so it is happy to say both are equal. Whereas when you say object, the memory location will have a value like an object ID, okay, which is like some random number like this, like an address location, okay, object ID. So it's trying to compare the references of those values, which can be different, and that's why equals double equals will return false, though both are actually same object. Like if you are trying to derive the object value equality, instead of doing this, you should be doing this. Okay, so if I do this, see, I entered equals. So understood the difference? Like double equals checks just the reference values. If you want to check the object equality, that's when you use equals. So the difference between these two is, if you are checking the reference values for objects, it can never be equal. Like if you are trying to see the value of the object, then go for equals, dot equals. Okay, very, very important. um, if you have any questions, ask me right now. Like a whole interview can go on one of these methods, and they can judge you whether you know Java or not. Okay, you will know it eventually, like you will evolve this meaning over classes, but this is very fundamental definition. Like, okay, double equals, like equals and double equals method. Okay, if reference values refer to the same object. Okay, equals method is overridden in classes in order to return true if the contents and type of the two separate objects match. Say for example, if we have two different employees, how are we, like two different employees with name Ravi Nukala, how are we going to say whether they both are same or not based on their employee ID, right? So in the same way, we are going to give a implementation to equals, saying like if employee IDs doesn't match, then they are not same person. Don't look at their names. Okay, so that's how we override the equals methods. Like if you have two different employee, this makes more sense once we introduce oops totally. But for now, remember this string example, and feel free to share this example in the interviews. That's when they'll know, oh okay, you know what a double equals and equals is. Okay. Okay, casting. If information is lost in an assignment, the programmer must confirm the assignment with a typecast. Say, for example, this is what I was talking about before, like big value. And if you are trying to typecast it to int, you got to specify it because you are losing some bits. So they just want to be sure that it's not Java bug. They want to make it to the application programmer, throw it on application programmer that he casted it. That's why we lost some bits. Okay. And long is an like even if you don't say 6L, it's going to consider it as integer. Okay, and then integer, if you have this assignment, it says it is illegal. You got to typecast it to int. Making following it, like if you have higher bits, long has like what, 64. So though you don't specify anything here, it default consider it as int because It is 32 bit, so it can accommodate 32 bits, so it doesn't complain about it. But whereas here what is it doing? It is lower 32 bit, and we are trying to assign something like a 64 bit number. So it says like it is illegal, please explicitly cast it. Okay, fine. Then promotion and casting of expressions. Variables are automatically promoted to a longer value. That means while running a multiplication, say suppose two integers, longer integers, it may result in a long, right? So it derives a long number. So during runtime, we may it if you don't cast it properly, it may throw an error. Okay, so they get promoted automatically. That's why this auto boxing and unboxing are actually helping a lot these days. Expression is an assignment compatible if the variable type is at least as large as the expression type. Branching, like if and else, if this one block, else one block. We know this already. Yeah. Switch case. What is this switch case? Okay. Switch case syntax is switch the number, and you have cases like okay, if the number is 1, execute some statements. Number is 2, execute some statements. If none of these match with the number that you passed, default execute something. Okay. And here is the problem. Whenever you are writing switch cases, make sure you have a break everywhere. Otherwise, if you don't put a break, it executes this case and also this case. And if you have a break, that's when it stops. So that means you may get into undesired behavior if you are using switch case without proper break statements. Okay. So, and it will be tough to debug as well. You are expecting something, a value is being passed properly, and why it is doing a different behavior. So that's how we get into troubles. Okay. And pre Java 7.0, you cannot pass a string to switch case, but with 7.0, you can pass strings also to switch case. Okay. Relational operators, A greater than B, A less than B, yeah, all this. Okay. Ternary operator. Somebody was talking to me about ternary operator, right? Yeah. So A greater than B, Ravi, else this. This is just a ternary operator, is another representation of if and else. Like it's like a complicated expression. We just put it in together. Okay. This expression prints out Ravi if it is true. If it is false, it prints out Kiran. Okay. This avoids writing if and else statements. Fine. Looping statements. Do you want to do loops? This loops may go a little bit like we have various kinds of loops and all that. Are you guys okay to take it today, or do you want to continue tomorrow? Loops may take a little bit longer, and we want to do some examples on loops and all that stuff as well. But in general, why loops are used is to repeat some task. Like if a condition is there, if you want to increment it and try out like 10 or 15 times or n number of times, you use loops. We'll talk about loops tomorrow probably. Otherwise, it will be too much today for today probably. Okay, so we are on slide. What slide is this? Okay, go back. Okay, so we are on yeah, we are on slide 59. We can continue tomorrow on this. In the meantime, do you guys have any questions? I'm going to share the slides, slide deck, and also the instructions to install. Do you have any questions? I unmute all of you. If you have any questions, you can speak. Feel free to speak. Any questions or comments on the timings? Feel free to speak. Okay. I just want to bring something up. Actually, one of our participants, Rini, she's in East Coast. I think rest of the people are in West Coast. She actually requested earlier than 6, but I said it may be a little, even 6 o'clock itself. I am actually making you guys awake on the weekend. Uh, but I'm not sure. Like she was asking for 5 to 8, but I don't know how others feel. I don't know, but it may be a little too much. Was my thought. Um, Renee, if you want to comment, you can comment, and all of you can decide on the timing if you guys want to.
Ravi, it's okay.
It's
It's
okay.
fine.
Yeah.
Yes.
Okay. Yeah, 5 o'clock maybe. Even today, I faced it a little difficult to wake up at 5:30. So yeah, 5 o'clock will be like little more. All of us will be sleeping probably. Okay, that's good. So we don't have concern on timings, and let me know like if it is too slow or too if it is going out of your head. Let me know. Like I can probably adjust accordingly. Okay, fine. If you don't have any questions, we can meet tomorrow 6 a.m. Pacific time.
Okay.
Okay.
Yeah. Okay. Okay. I'm going to end the meeting. Yeah. Okay. Thanks.
Okay, thank you.
Thanks. Bye.
Ravi,
Yeah.
you are going to share the recording, today's recording?
I do. Let me actually stop the recording while we are speaking.
Okay, thanks a lot.